In section 8.5, we're going to look at the law of sines. Now, the law of sines is going to be used if you've got any type of triangle, so acute, obtuse, or right. Actually, really just acute and obtuse, because you can do other things for right triangles. What it's going to be is if you're given, say, two angle measures and then a third, and then the measure of one of the sides. You can then use this law of sines to be able to determine what are the lengths of other sides. So the actual formula is sine of A over A equals sine of B over B equals sine of C over C. And remember that A, B, and C in the denominators represent the length of the sides, whereas A, B, and C in the numerators represent the degree measure of the angles. Now, when you do this, you're only ever going to use two of them at a time. So you might use A and B, or you might use B and C, or you might use A and C and just forget B. But what you want to do is think of it as the transitive property. If you can use it for A and B, you can also use it for A and C. It's a little bit easier to explain with an example. So what we're going to do is this. We're going to say that if we want to find, we've got, let's see, this is C up here. We have A, and then we have A over here. We have B, which is given to us as 15, and then we have C down here. So if we're looking for the length of A, we can use the law of sines. The way that we're going to do this is to say the sine of A is the sine of 48 degrees over the value that we're looking for. So sine of 48 over A equals, and then we're going to make a proportion. So the other angle that we have is B. So we're going to use the sine of 93 over the value of B, which is 15. So now that we've got this, we can just go ahead and cross multiply in order to be able to solve this. So we're going to get A sine of 93 equals 15 sine of 48. Now, to get rid of this sine of 93, since it's being multiplied against the A, we just divide it out. So divide out sine of 93 from both sides, and you're going to get that A is equal to 15 sine of 48 over sine of 93. Now this right here is going to be the more accurate answer because that is still in trig ratios. So if we were doing if we had to do other things, like we're going to do later on in chapter 10, where we've got to figure out a lot more information, we would want to keep this like this. But since we are done with this problem, we can go ahead and run this through the calculator. So go 15, and then sine of 48, close out the parenthesis, divided by the sine of 93. So sine of 93, close out the parenthesis, and that is 11.16. So we get A is approximately 11.2 units long. So this is how you're going to use the law of sines. Again, you're given two values here for your angle measures. You're given the opposite side for one of those. So to get this side, you're going to use the law of sines, work out the proportion, and then run it through the calculator to find out what the decimal answer is going to be. In problem number 2, we're going to use the law of sines to find an angle measure. So this means that we're going to need to use the inverse sine in order to be able to solve this. So keep that in mind as we go through this problem. So we're looking for this particular angle, and we're given the side across from it is 11. Then we're given that angle R is 120 degrees, and the side across from that is 18. So let's go ahead and set up using our law of sines. So we're going to go the sine of S over 11 is equal to the sine of 120 over 18. All right, so now go ahead and do your cross multiplication because we're working with proportions. So we get 18 sine of S is equal to 11 sine of 120. Now again, because this 18 is being multiplied against the sine of S, we can go ahead and divide that out in order to figure out what sine of s is. So we get sine of s is equal to 11 sine of 120 over 18. Now we can't reduce this at all because 11 and 18 don't have any common factors. But now that we've isolated the sine of s, we need to now make this the inverse sine of s because we're looking for an angle measure as opposed to a side length. So you're going to take your calculator out at this point and you're going to punch in inverse sine of 11 sine of 120 and then close out that parenthesis divided by 18 and then close out the parentheses for the inverse sine. And that's going to give you 31.9 and that's going to be approximately 32 degrees. So we know that the degree measure of S is going to be approximately 32 degrees.